excuse me, can review the graphing part a little bit, sure. All right, so I got these questions here. Dalal, can you hear me okay? Is the volume on? I just want to make sure I'm not just kind of talking. Okay. Okay, I don't remember how far we had gotten today, but I feel like we did 1 and 2. Dalal, since you're here and responding, do you want me to start with 3? Up to you. Okay, so let's take a look at 3. So if I'm starting off with 3, I'll just do the whole thing and then we can kind of jump in and out. So this is number 3. So, excuse me. So right away, this is in standard form. I know my y value is, my y-intercept is going to be -2, so that's taken care of. I then go to the roots on this. You can try to go to charting directly, but if you want to do a check, you can kind of see where you're at with this. If I go ahead and calculate that discriminant, you'll see here I end up getting, what is this, 81 plus 40 is 121. That is a perfect square, right? So like we talked about, that's a perfect square. So I should be able to factor this using charting. Let's go ahead and do that. So if I do charting on this, you do the factors of 5, factors of -2, and I need this to come out to be a 9. It's going to be these two. So, I mean, a lot of work, but this ends up factoring to 5x minus 1 times x plus 2 is 0. So the roots here are a fifth and -2 become my roots, right? And again, if in case you've forgotten, you can solve, you get a fifth, and solve, I get -2 for these two. So I've got my y-intercept, my roots. If I want to continue this, I need to find the axis of symmetry. For your axis of symmetry for here, it's in standard form. So go to right to x is -b over 2 times a is -9 over 10. So I have my axis of symmetry. If I want to find the y coordinate, I have to sub this back in. Now, this got a little messy, I think. This is going to get a little messy. So I am getting here 5 times 81. So this is 405 over 100 minus 810 over 100. So again, I multiplied top and bottom by 10 to get a common denominator with that one. Actually, I'm probably in the way. You can't see good. And lastly, this will be 200 over 100. Again, depending on what calculator you have, you probably can get it done in one shot. So this ends up being negative 605 over 100, which I can reduce that to, I mean, if you just aren't sure, you just divide by 5, you get 121 over 20 just by dividing by 5, just to reduce it a bit. So again, this is divided by 5, divided by 5. I'll try to keep the numbers a lot more, a little cleaner than that on the quiz. So, sure. So the question here, the vertex of this is negative 9 over 10 and negative 1. Well, I mean, these have tons of fractions. You mean the original, like the quadratic itself has fractions. Sure, I can do that. Okay, so I've got my axis. I got my y-intercept, my roots, axis of symmetry, the y-coordinate, my vertex. I can put this all together and be done with this. So if I put this all together, the a value is my leading coefficient, so that's going to be 5. So this is going to be 5 times x minus my h value, which that's my h value there, right, all the way over here. It's my h value, so it'll be x minus negative 9 over 2, so 9 over 10, so it'll be plus 9 over 10 squared, and then there's my k value. So that's vertex form. The part that Dalal was asking, the sketching, the only thing I need for the sketch is draw your x-axis and your y-axis. You can draw that as well. You know the vertex is negative and negative. See the two negative signs? So I know it's somewhere in this quadrant. It's kind of like going over a bit, then down much more than that. So maybe somewhere here. And the leading coefficient is positive, so this opens upwards. In fact, I have the roots. I know the roots are negative 2 and a fifth. See, my roots here are negative 2 and a fifth. So one of the roots is negative, the other root is positive. So I'm going to draw it like, and again, this is just intended to be a sketch. So it's going to go slightly this way and like that. I know this is a fifth. I know this is minus 2. I know right down the middle, this is x equals my h value, which is negative 9 over 10. And that is everything. That's all you need to do for this one. Okay. So that one is done. Do you want me to give you some time to work on this one? Like to try this one on your own? Hey, Mina. Why don't you guys try this one on your own? And then, like, I can kind of think about some other questions if you want. Dr. Saturn, here you go. Okay, so this one here, you can give this a shot too. No problem. Did we get this for the y-intercept? Y-intercept's 13 for this one. Now this is what I was talking about regarding the x-intercepts. You don't want to, in this question here, if you take a look at this question, right, I don't want to have to expand this all out and then do the quadratic equation or factor at that point. What you want to do is you want to solve this using your solving in vertex form. It's just a lot quicker. So I'm going to add 5 to both sides instead. Right, I'm going to add 5 to both sides, then divide by 2. Right, then I can take the square root of both sides. Right, 5 over 2 doesn't simplify at all, so I'm just going to leave it like that. Then I can go ahead and add that 3, so I get plus or minus the root of 5/2 plus 3. And that becomes my x-intercepts. Again, like we talked about, you have a question in vertex form, right? To find those roots, you don't want to have to expand everything out, simplify, then use the quadratic equation, which is what you would have had to have done. Instead, it's much better to set y equal to 0, and then take the 5 and bring it to the other side through addition, divide across by 2, and you've kind of isolating. Then take your square root with the plus or minus. Don't forget the plus or minus. There's 2 options that satisfy that equation, right? And then add the 3. So this becomes my roots here. Sure. Oh, you know what? You might have missed it. We just did it above. We did it right here. I think you can go back and check it out, but I have the solution. Sorry, what you're saying, so the plus minus equation is your 2 roots. Yes, those are my 2 roots. So again, to remind you, what does this mean? One root is positive, so it'll be root of 5 over 2 plus 3. The other root is negative. It would be negative root of 5 over 2 plus 3. And these are my 2 roots. Notice if I take these 2 roots and I add them together and I divide by 2, these are going to cancel. You'll get 3 plus 3 is 6. Then if you divide that by 2, you get 3. That's exactly my axis of symmetry, right? The axis of symmetry of this is 3 because you know the vertex. You don't need to know that though because it's already in vertex form, right? So I know my vertex of this quadratic is 3, negative 5. So therefore I know the axis of symmetry has to be x is 3. And I'm already in vertex form. Right? So now you can quickly do a sketch of this. It's not too hard. Just go like that. The vertex is 3, negative 5. So back to Delal was asking about graphing. Vertex is 3, negative 5. Maybe it's somewhere here, roughly. Now, one root is negative. If you take 5 over 2, both roots end up being positive. So both of these are positive numbers. So your roots it's gonna kind of look like this. Right? This becomes my quadratic. Right? The reason for this is both of these are greater than 0, so they're on the positive side. My roots are approximately here and here. Right? I can label this x1 and x2. This is x1 and this is x2. Right? And then right down the middle here, it's not showing up. Right down the middle here is my axis of symmetry. X is 3. Okay, so there's this one here. There's 4. Take a look at. Is this okay? Are there any questions with 4? How that was done? Okay, I'll take a look at 5. Okay, I'll give you guys at least a couple of minutes to try this out. So try 5 out on your own. So I don't know if people have gotten to it. Why does the sketch not cross over the y-axis? Well, the y-intercept here is 13, Gurman, so eventually it will. I can, like this graph I've drawn here, I can extend this. Eventually, if you keep going off, it'll cross. Every quadratic has a y-intercept. You can't graph a quadratic that won't eventually cross the y-axis. So these all eventually will cross. Okay, give this one a shot, see if you can do it. Okay, so just to start you off, if you are working on this one, I did go ahead and calculate the y-intercept already. Again, the y-intercept is not 1. You have to go ahead and let x equal 0. That's what I did here. I let x equal 0 and solved. This y-intercept is 4. Continuing on with this, you go ahead and find your x-intercepts. Again, the roots or x-intercepts, you can set y equal to 0 and solve it. So I go to solve this. What happens here is I go to subtract 1 on both sides. And right away I got a problem. I divide across by 3. And we had talked about this in class. You can see here that this is positive and this is negative. So no solution exists here. Right? You can't, this is always positive, this is always negative. There is no number I can square that's going to result in a negative number. So this equation will never be solvable for the real number system. So no real numbers exist that satisfy this. This has no real roots. And that's what we see in this example here. So if I go to number 2, it's asking for the roots. And the answer to this is no real roots. Right? Which actually should have been, would have been obvious if you would have tried to sketch this. Yes, for sure. Could definitely happen. Not no solution, but no solution for the roots. Yeah, definitely, Mina. But you would have seen it by sketching it too, because take a look. If you go to sketch this, the vertex, right? The vertex for this is 1, 1. So I have my vertex is here, but the quadratic opens upwards. So you know it's looking something like this. So you can see here it's not crossing the x-axis. So we have no real roots. Sure. Could you go over what exactly we're looking for once given a quadratic? Yeah, the questions are going to be, the questions you get are the same questions in the homework. Like the same things I've asked in the homework. So I'm going to ask you for, if that's what you mean by your question, I'll write it over here. I'm going to ask you for the y-intercept. Then I'm going to ask you for the roots. And then it'll say if any. Then I'm going to ask you for the axis of symmetry. Then I'm going to ask you for the vertex. Then I'm going to ask you to put the quadratic in vertex form. And then I'm going to ask you to sketch. Those will be the questions. The quadratics you get will be like the mix-ups of the ones I've kind of given you. We've done like maybe, feel like we've on our third worksheet like this. Okay, Dr. Saturn wants this example here. Here, actually, let's do it here. Good question, Marie. All right, so like we had talked about here, I've got my y-intercept, boom. I'm in a situation where I have no real roots, so we know this doesn't cross the x-axis. If I go to part 3 here, right, if I go to part 3, they want me to find the axis of symmetry. Well, like Marie was saying, I don't have any roots, so I can't add them up and divide by 2. That does not mean it doesn't have an axis of symmetry. Because your axis of symmetry is the h value of your vertex, I'm just grabbing my h value right here. I know my vertex is 1, 1, so the axis of symmetry is x equals 1. Right? Is that clear, Marie? So, and then in 4, they want the vertex, I believe. The vertex is 1, 1. Vertex form, it's already in vertex form, so there's not really much to do with this. I just rewrite the whole question. Yep. Yeah, I mean, you can also go to standard form and do it. It just would take a lot longer. But yeah, here, I can do it right here just to show you. Obviously, it's much quicker to not go to standard form, but let me just write this down. This is the question. So if I did expand this question out, you could do the negative b over 2a thing. So now the person who had asked this, now I'm in standard form. So if you do the negative b over 2a, I'm going to get negative 6 over 2 times 3 is exactly equal to 1. So you get the exact same answer as before. Right? So you know, I was in vertex form right here. So I already have my axis of symmetry sitting here as 1. But if for some reason I forgot and I expand everything out as Mina had suggested, and I got this quadratic in standard form, you can do negative b over 2a and get your axis symmetry just the same. So that is an option as well if you want to go ahead and do that. Right? Like an example would be like question 1. Oh, sure. I can do question 1, Diva. Just to continue what we were talking about, back to Marie's question, and I got to do this one here as well. Matthew was asking this one. Back to the question we were talking about. Let me paste Dima's question so I remember. Back to Marie's thing, like if you have a quadratic without roots, but what would you do if you have a quadratic without roots? So let's say I gave you a quadratic without roots. So this one right here, x squared plus x plus 5. If you go ahead and calculate your discriminant on this, you'll find that this is going to be less than 0. This does not have any real roots. So if I asked you for part A, the y-intercept is easy. You wouldn't have a problem with that. You know the y-intercept is 5. The roots, there are no real roots. Your discriminant is less than 0. So if I want to find the axis symmetry, it's a little more difficult because I don't have this in vertex form. So then I'd have to do the negative b over 2a formula. So hopefully that clears it up, Marie, the whole thing. And you get your axis symmetry of -1/2. For this one. Okay. This one here, someone had asked for a question with fractions, so I just kind of made one up with fractions. So if you want to find your y-intercept, that's easy. That's just 3. If I want to find my roots, I can set y equal to 0. And I think what I was getting at here is you can multiply across by 2. And then I can try to solve this one. So this will probably be a charting question. Since I made this up, I believe it factors using charting. You'll have to use all minus signs here to make it work. And I need to get a -11. And that'll be this and this. Oops. You get -8 minus 11, negative 11. So did you get this far? You get roots at 4/3 and 2? for this one? Okay, good. So y-intercept check, roots check. It could be a little bit messy. Like I said, I just had made it up. So if I had to do the axis of symmetry, both are messy. I would just do it adding up the roots and dividing by 2. So if I add up these roots here and divide it by 2, you're going to get 3/4 plus 8 over 4 divided by 2 is 11 over 4 divided by 2. And this is actually over 1, so you can multiply by the flip. I got 11 over 8. I don't know if you were able to do all that math. But the vertex here, or my axis of symmetry, I should say, is 11 over 8. Oh, why is it 3/4 for 1 root? To find the roots, you're going to set this equal to 0. Right? So for this question, you're going to go ahead and have 4x minus 3 equals 0, which means 4x is 3, x is 3/4. Why did I put -3 and -2? Shouldn't there only be one negative? Good. Where do you see -3 and -2? Oh, no, you need 2 negatives because the 2 negatives is positive. All right, I need this to come out to be a positive 6. So -3 and -2 will combine together through multiplication to give me that. Is that okay? All right, so there we go. And then you give your vertex and all of that sort of thing. Deem, are you still there? Scroll down a bit, sure. Again, more fractions. Oh my goodness. Okay, while you guys are copying this, I'll work through this question with Dima. The y-intercept here the axis of symmetry. Well, if you're good with the roots, that means I added up the roots and divided by 2. Okay. So Dima, with this question here, what you want to do is let x equal 0. And you're going to get here 3 times -7 times 3, which is 9 times 7. I'm going to get -63. That becomes my axis. That becomes my y-intercept. So I have a y-intercept of -63. My roots are easy. My roots of this are just going to be 7 and -3. It's already in factored form. My axis of symmetry, I'm going to add up these roots and divide by 2. Because I have the roots available to me, I get my axis of symmetry as 2. To find the y-coordinate, you sub it back into your original, letting x be 2. And I get -75. So therefore my vertex is 2 and -75. So now I've got my roots, I've got my axis of symmetry, and I've got my vertex for number 1. So vertex form is y is 3, x minus 2 squared minus 75. So there's my y-intercept, my roots, axis of symmetry, vertex form. No problem. Okay, so there's another one here. What's next here? Someone had requested me to make up some questions with fractions. I can do that. Does anyone want to continue these ones first? I've got a chunk of questions here that we can work on as well, like number 6. If you want, we can do number 6 here. Let me paste that. I'll let you guys try this out. Oh, right here. There you go, Marie. Oops, sorry. All right. Here's the question. If you guys want to work on this one, I'll let. Because when you, Gurman, with this one here, I have a fraction divided by a fraction. You can change the division symbol to multiplication, but you have to flip this fraction. So 2 over 1 becomes 1 over 2. That's how I got the 11 over 8. Yeah, for sure, Diva. As long as you're, as long as it wasn't just a coincidence. For sure. You flip it because you're dividing. In this question here, I got 11 divided by, I had 11 over 4 divided by 2. I wanted to evaluate that. So I had to put it over 1. So I have a fraction divided by fraction, in which case I can change it to multiplication, but you have to flip, which is 11 over 8. Is this 6 right here, Mina? Yeah, if you do this one, a quick discriminant check tells me I get b squared minus 4a. Yep, you're right. The discriminant here is 4 minus 20 is less than 0. So this has no real roots, this question. So my y-intercept is easy to find. The y-intercept is going to be 5. we just talked about the roots, and the roots are no real roots. And like we talked about, the discriminant's less than 0. Yeah, for sure, Gurman. Give me a second. Then the axis of symmetry, because I don't have the roots, just do negative b over 2a. So this will be negative b over 2 times a. The axis of symmetry is x equals minus 1. That's my axis of symmetry. I want to find my vertex, so I'm going to let x be negative 1 here. So I'm going to get y equals negative 1 squared plus 2 times negative 1 plus 5. I'm going to get 1 minus 2 plus 5 is equal to 4. So the vertex for this is negative 1 and 4. So now you see I have my vertex, and I know my leading coefficient is a 1. So vertex form here, this is my vertex. Vertex form is y is x plus 1 squared plus 4. For sure. So now if I want to graph this, do your Cartesian plane. The vertex of this is negative 1 and 4, so it's somewhere right about here, let's say. There's my vertex. I know that this quadratic has a leading coefficient that's positive, so I know it opens upwards. So it's going to look like something like this, right? Something like that. I don't have any roots, so I don't have to worry about plotting those. My axis of symmetry just cuts the quadratic in 2 equal pieces. X equals what? X equals minus 1. That's it. I mean, if you want to, you can see we cross the y-axis, so I know this is the point 0.05. I know I have my vertex here of negative 1 and 4, and there's not really much else to label on this sketch here. I've kind of got everything. Right, so that is that one. Okay, so there's this one here, and then Gurman wanted the graph of this thing here. What the heck was the vertex for this? I've lost track of where I'm at with this one. You know, Gurman, this one here, I made this one up because someone just wanted to see an example with fractions. The h coordinate is 11 over 8. If I sub it back into this, it's super messy. Unless you tried it and you want to check your answer. But else I would say it's not worth going through because the numbers will be really messy on this one. How I graph question 3? Here's question 3. Well, in question 3, the x and y coordinates of the vertex were negative. So I'm in this quadrant here. And it opens upwards. Now, what I did was, because we already found the roots, I know one root is positive and one root's negative. When I graphed my quadratic that's opening upwards, I didn't graph it like this because it would be inaccurate, because that would mean I have 2 negative roots, which is not the case. I have 1 negative root and 1 positive root. So when I graphed it, I try to make it so it crosses on the positive side as well, so I could catch both those roots, 1 negative and 1 positive. Right, as opposed to doing it like this. Right? Both would be negative, which is not the case. All right, number 7. Yep. For number 7 here, the y-intercept is negative 20. Again, how I did that is just let x equal 0. If you let x equal 0, then that cancels off the 4, and you've got negative 20 for your y-intercept. They want the roots for this one here. There's a bunch of ways you could do it, but if you're looking for the roots, you can set y equal to 0. You can add 20 to both sides. Divide by 4. And then take your square root of both sides of the equation. Right, so I added 20. Divided by 4. So 20 divided by 4 is 5. And then you just take the square root of both sides. It gives you plus or minus root 5. So these are my roots for this question. Okay, so I have my y-intercept and I have my roots. The next thing I want to find is my axis of symmetry. But that's really easy because this is in vertex form. This is really x minus 0 squared minus 20. So this has a vertex of 0 minus 20 is my vertex. So the axis of symmetry here is just x equals 0. In part 4, they want the vertex. Well, we already have it. I'm in vertex form. So 4 and 5 are easy because you already are in vertex form. Now they just want a sketch for 6. So draw your Cartesian plane. My vertex is 0 minus 20. And you'll notice that the quadratic, the leading coefficient of my quadratic is, the leading coefficient of my quadratic is positive. It opens upwards. So we're going like this. And one root is root 5. The next is negative root 5. We've got a axis of symmetry here of x equals 0. Yeah, for sure. You can do difference of squares, Marie. So like the only problem with this one is if you did do difference of squares, you can factor out a 4, but you end up getting x squared minus 5, so it's not a perfect square, but you can write it as root 5 squared like that. So that'll be x minus root 5, and then x plus root 5. Sorry, I realized I think I was off the screen. Right, so you can factor out a 4 and then rewrite the 5 as root 5 quantity squared and then do difference of squares. Right, and then if I set this equal to 0, if you wanted to, this one's maybe a little trickier. So therefore either this is 0 or this is 0. Those are the two options. So x minus the root of 5 is 0. X plus the root of 5 is 0. So either x is root 5 or x is negative root of 5, i.e. the plus or minus root 5. Okay, so there's 7. Oh my goodness, fractions. Okay, let me think of one here. If you're looking for fraction practice, as requested, this would be one you could try. Yes, 4 questions. All right, I'll let you guys try this one out and I can take it up. All right, so let's continue this one. So someone was asking for work with fractions. The y-intercept here is easy. Nothing really changes. You should have gotten a y-intercept of -3. The roots, you set this equal to 0. And the idea with the fractions is you can just multiply across by 2. So this will be 0 is what, 2x squared plus x minus 6. So now what happens here, if I check my discriminant, what do we get? B squared minus 4ac. I get the discriminant is 1 plus, end up getting here 48. So I actually get 49 on this here. So we actually could have solved this using, this is a perfect square, so I could do this using charting actually. Let's go ahead and just solve it using charting just to see this, kind of work it out here. And I'm looking here for, it's got to come out to be a 1. Which case is these ones here. And I get 0 is 2x minus 3 times x plus 2. So the roots are 3/2 and -2 for my roots. Okay, so I'm getting roots at 3/2 and -2. Did anyone else get those as well? Okay, good. So now that you have those, if I had to do the acts of symmetry, you can add these up and divide by 2. Or Dalal, back to what you had were asking me earlier, this is in standard form, right? So it's going to be negative b divided by 2 times a. So it's going to be -1/2 divided by 2. And you see here, this is over 1. So, you know, this is going to equal the fraction, change it to multiplication and flip, and I get -1/4. Right, so I end up getting here the acts of symmetry. I've got my roots here. So the roots for this one, now again, I made this question up, so it might be a little messy. 3/2 and -3, -2. The acts of symmetry is x is -1/4. Sum it back into the original to find the y coordinate. So you're going to have -1/4 squared plus 1/2 times -1/4 minus 3. I get 1/16 minus 2/16 minus 48/16 if I got a common denominator. So this ends up being here -49/16. So the vertex for this is -1/4 and -49/16. So the y value here is going to be a. If I put this in vertex form, my a value is a 1. So it'll be x plus 1/4 squared minus 49 over 16. All right, and that's my answer for this one. If you go to sketch it, it's going to be somewhere down here, but you know the roots are 3/2 and minus 2. So one side will be positive, the other will be negative. This is minus 3/2, this is 2. That's my axis of symmetry in the middle of x equals minus 1/4. Oh, sorry. I mixed up the signs. This should be negative and positive. It's positive 3/2. Thank you, Mina. It's positive 3/2, so it should be there, and then negative 2 should be there. Okay, so there's another example with fractions. All right, is there anything else to go through you guys need? I don't know. Oh, I guess we might as well do, we've done 7. I have not done 8. Here, I can go through 8. As well. Unless, is there something specific people need help with? All right, so for number 8 here, the y-intercept here should have been minus 3. That's easy enough to find. The x-intercept, or I should say my roots, or your x-intercepts. Quick discriminant check on this is, I think I made all of these. This is what, 16 plus 12. You end up getting 28. So I'm gonna have to use, oh, sorry, Gurman. How would you find the axis of symmetry for the question above? Plus or minus root 5. Didn't I answer that? Oh, right here, the axis of symmetry is 0. For that one. If you have a root at root 5 and a root at negative root 5, right? Like if you have a root at root 5 and negative root 5, you add them up. Well, you can add them up, divide by 2, you get 0. But what happened was this question was already in vertex form. So the question you're asking, we were already in vertex form. I rewrote it like this in vertex form. So I know the vertex was 0, negative 20. So there's my axis of symmetry right here of x equals 0. But if you don't view it that way, what you can do is when you get your roots, which are these ones here, plus or minus root 5, if you take root 5 and then add it to negative root 5 and divide that by 2, you're going to get 0 over 2 is 0. Yeah, no problem. Okay, on to the last question here. We've got y is x squared plus 4x minus 3. So discriminant check tells me that it's greater than 0, but it is not a perfect square. So we're going to go ahead right to the quadratic equation. So the roots are going to be x is negative 4 plus or minus the root of 28 over 2. And now I've got my roots, and now I have my y-intercept. So y-intercept and the roots. We've got y-intercept, we have our roots. I need to find my axis of symmetry. It is in standard form, so you're going to get negative b over 2 times a is negative 2. So I have my axis of symmetry. To find the vertex, I need to sub this back into the original, so I'm going to get rid of that x and change it to a minus 2. And see what we get here. So if I calculate this, I get 4 minus 8 minus 3, and I get negative 7. So the vertex for this is negative 2, negative 7. So I've got my vertex as well. I've got my axis of symmetry. And then I'm set. I can do vertex form. Vertex form is going to be y equals a, which is 1, x plus 2 squared minus 7. So there's vertex form as well for this question. So then we can do a quick sketch. The vertex is, like we talked about, is negative 2, negative 7. So it's like somewhere here. The quadratic opens upwards. The leading coefficient is 1. We can see a 1 here and a 1 here. So it's going to open up, and the roots are positive and negative. So one root's going to be on the positive side, the other root's on the negative side. So this is negative 4 plus the root of 28 over 2, and this is negative 4 minus the root of 28 over 2. Exactly in the middle is your axis of symmetry, which is x is negative 2. And that's it. Well, your axis of symmetry, well, I got the axis of symmetry as minus 2 because you take your negative b value. I took my negative b, so negative 4. Got it right from here. Divided by 2a. A is 1, so negative 4 divided by 2 is negative 2. So axis of symmetry is negative 2. How did I find the roots? I found the roots by calculating the discriminant, and I got it was 28. So I realized I needed the quadratic equation. So negative b plus or minus the square root of my discriminant over 2a. My a value is 1. So I'm just multiplying of 2 times 1. No, I didn't use the roots to find the axis of symmetry. I just used the fact that I was in standard form. I just did negative b over 2a. And then to plot it, to sketch it, I just plotted the vertex right here. And then did the direction of opening. I don't get how to plot the vertex. Where's the fractions? There are no fractions. The vertex is -2 and -7. I see no fractions here. Oh, when there are fractions? Okay, here, I'll make up an example. Watch here. Let me show you. Let's say we have this question. I'll make this minus. And let's just put, oh, I guess you want fractions. So, okay, 10/7. Just some nasty numbers. If you go to sketch this, you're not sketching it like you did previously in your previous classes, like a meticulous graph. It's just a sketch. So in this case here, the vertex of this is 1/3 10/7. So 1/3 and 10/7, I'm just very roughly saying it's maybe right about here. Super rough because you don't really need it to that accuracy. And it opens downwards. So my sketch is looking something like this. That's it. That's all you're doing. I know the vertex. Maybe it's there, and I know it opens downwards because the leading coefficient is negative. I could be wrong here. Like this graph might be over here and here, right? It's not precise. I haven't found the roots yet. Like earlier I had kind of found the roots, so I know what's, if it's positive or negative side. But like these could both be on the positive side. The roots could both be, or one could be on the positive side, one could be on the negative side. I'm not really sure because I didn't actually find the roots, but that's all I'm looking for. The whole purpose of the sketch is just so that you know how many roots it has, right? Like this quadratic, I know it has 2 roots. I don't know exactly if they're all positive or negative, what that may be, but I know a rough sketch of it. That's it. Right, and I've got it going through the y-axis. It might look something like this, for all I know. Right, or it might look something like this. Right, or like this. I'm not sure. I'd have to find the roots to decide in more detail that portion of it. Okay, are there any other questions? Okay, we'll stop it here. The stream will save all the work we did, so you can review it now if you want. Like if you want to go through the questions yourself and kind of review the work we had done, it'll all save and you can check it out now. So good luck tomorrow. We'll do that the first half of class and go from there. All right. Okay, I'm going to, unless there's any last minute questions, I'll end the stream now. Does anyone have any last minute questions? See ya, Kinlan. See ya, Dia. All right, see ya, German.